This video discusses how to evaluate piecewise functions. A piecewise function is a function defined in terms of pieces of another function. So we're going to use one function for certain x values. We're going to use another function for other x values. Given that g of x equals x plus 5 when x is strictly less than -2 and x squared minus 6 when x is greater than or equal to -2, we want to find g of -6 and g of 2. The way that we read these piecewise functions is this second portion where it has the inequality with the x. It tells us when we want to use the corresponding function to the left. So when x is strictly less than -2, we want to use x plus 5. And when x is greater than or equal to -2, we're going to use the function x squared minus 6. We're going to start by evaluating g of -6. We need to decide which of those two categories of x values does -6 fall into. Is -6 less than -2, or is it greater than or equal to -2? -6 is less than -2. Therefore, when evaluating g of -6, we want to use x plus 5. So we're just going to plug -6 in for x like we normally would when evaluating a function in function notation. -6 plus 5, g of -6 equals -1. Next, we want to evaluate g of 2. Our x value is 2. We need to determine which category it falls into. Is it less than -2 or greater than or equal to -2? Positive 2 is definitely greater than or equal to -2. So we're going to use x squared minus 6 when evaluating. Plugging 2 into x squared minus 6, that'll be 2 squared minus 6. 4 minus 6, we get g of 2 to be -2. Let's try another one. Piecewise functions can have more than just two parts, so you'll see this piecewise function has 3 parts. Given b of x equal to 2 times the absolute value of x plus 1 when x is strictly less than 4, 8 when x is equal to 4, and the cube root of x minus 4 when x is strictly greater than 4. We want to find b of -6, b of 4, and b of 12. Let's start with b of -6. We turn our attention to the x value of -6. We need to determine which of these categories the x value falls into. Is it less than 4, equal to 4, or greater than 4? -6 is definitely less than 4. Therefore, when evaluating, we're going to use 2 times the absolute value of x plus 1. 2 times -6, 2 times the absolute value of -6 plus 1. That's 2 times the absolute value of -5. We know the absolute value of -5 is +5. Be sure to maintain that operation of multiplication. 2 times 5 is 10. So b of -6 is equal to 10. Next, we want to find b of 4. Looking at our x value of 4, we need to figure out which of these categories it falls into. Is that less than 4, equal to 4, or greater than 4? 4 is equal to 4. So we're going to use the constant function 8. Notice that there is no x to plug the 4 into. All there is a standalone 8. So our answer is that standalone 8. Lastly, we want to find b of 12. We look at our x value of 12. We want to figure out which category it falls into. Is it less than 4, equal to 4, or greater than 4? 12 is definitely greater than 4. Therefore, we're going to use the cube root of x minus 4 when evaluating. Be the cube root of 12 minus 4. That's the cube root of 8. And we know the cube root of 8, that's a perfect. We get just 2. So b of 12 is equal to 2.